Every year, billions of tons of cargo cross the oceans, goods, fuel, and resources that power the global economy. And holding these massive ships steady in raging seas are chains built for one purpose: to resist the force of nature itself. Each steel link is forged under extreme heat, bent and welded with millimeter precision, and tested to survive hundreds of tons of pressure. One failure could mean the loss of an entire vessel and millions in trade. For decades, countries like Japan, China, and South Korea have led the world in producing these industrial giants. But how about the US? Once the symbol of maritime innovation, can it still forge the steel that keeps its own ships anchored at sea? This is how the world's strongest anchor chains are made, from start to finish. The journey begins inside massive steelworks where iron ore, carbon, and alloys are transformed into molten metal, the foundation of every anchor chain. Each year, global steel production surpasses 1.8 billion tons, but only a fraction meets the strength required for maritime chains. This specialized steel is engineered for tensile durability, corrosion resistance, and flexibility under stress, properties that allow each link to endure decades underwater. In the United States, only a few facilities still handle this level of heavy forging, sourcing raw materials from domestic mines and recycled steel. The molten mixture is refined at temperatures exceeding 1,600 degrees Celsius, removing impurities before being cast into solid billets. Every billet is tested for uniformity and chemical precision, a process that ensures that, from the first link to the last, every part of the chain holds equal strength. From mines to furnaces, from fire to form, this is where the metal that anchors the world's largest vessels begins its story. It's not just about steel, it's about engineering trust between man, machine, and the sea. Inside steelworks dedicated to maritime hardware, the process begins with massive billets of high-grade alloy steel. Each billet is heated inside a gas-fired furnace to over 1,000 degrees Celsius, softening the metal into a malleable form ready for shaping. These billets are cut into uniform segments, each one destined to become a single chain link. Robotic arms grip and feed them into hydraulic presses that exert hundreds of tons of force, bending the glowing steel into a precise oval. At this stage, precision determines safety. A single link failure at sea could mean catastrophic loss, so tolerances are measured to millimeters. Each formed link is overlapped with another, ensuring they interlock seamlessly before being closed by forge welding. The heat and pressure fuse the ends permanently, creating a joint as strong as the parent metal. For anchor chains rated for offshore oil platforms or super tankers, this joint strength is tested repeatedly during production. The newly forged links are now one continuous chain, still red-hot and flexible. They move through a rotating heat treatment drum, which gradually lowers the temperature under controlled conditions. This annealing process relieves internal stress caused by forging, preventing cracks when exposed to the extreme forces of the open sea. Once cooled, robotic handlers transfer the chain to an automated trimming station, removing any surface excess and sharp burrs that could compromise coating or strength. After shaping and cooling, quality inspectors perform ultrasonic testing on sample links from each batch. These scans detect invisible flaws inside the metal, microscopic voids or inclusions that could cause failure under tension. Only links that pass this internal check move forward. From here, the steel's transformation from raw billet to forged chain is complete, but it's only halfway through its journey. Next, the chain will face even harsher environments inside the heat treatment and proof testing stages, where each link is pushed to its physical limits before being certified for marine use. After forging, the chain is strong, but not yet strong enough for the ocean. The next phase is heat treatment, a process that changes the steel's internal structure to maximize strength and durability. The entire chain is fed through a continuous furnace over 100 meters long, heated to nearly 900 degrees Celsius. Every link glows orange as the steel's crystalline structure realigns, giving it the toughness needed to endure years of strain beneath the waves. Immediately after heating, the chain is quenched in massive cooling tanks filled with temperature-controlled water or oil. This sudden drop in temperature hardens the steel, locking in the new molecular structure. Each link is then tempered, reheated at a lower temperature to balance hardness with flexibility. Too hard and it could shatter under stress, too soft and it would deform. This combination of heat, quenching, and tempering ensures the metal achieves its ideal balance of tensile strength and elasticity. When heat treatment is complete, the chain's performance is put to the test. Sections are clamped into enormous proof testing machines, where hydraulic pistons pull with forces equivalent to hundreds of tons. These machines simulate real-world conditions: storms, deep-sea currents, and anchor drops from massive vessels. Each link must withstand more than twice its rated working load without permanent deformation. If a link shows even the slightest elongation, the entire section is scrapped. Following mechanical testing, technicians conduct magnetic particle inspections and X-ray scanning to detect hidden cracks or weaknesses. No part of the chain escapes scrutiny. Every meter is certified, logged, and traceable to its heat batch number. This level of documentation is mandatory for chains used on oil rigs, naval ships, and heavy marine construction. The final step in this phase is dimensional verification. Automated laser systems measure link geometry down to fractions of a millimeter, ensuring uniformity across thousands of links. These precise measurements are what allow the chain to function smoothly when running through winches and anchors. With heat treatment and testing complete, the chain has reached its ultimate strength. Engineered to survive decades in saltwater environments and extreme pressure. From here, it moves on to surface protection and finishing, where the focus shifts from internal durability to long-term resistance against corrosion and environmental wear. Even the strongest steel can fall to corrosion. After surviving the fires of heat treatment, every anchor chain faces its next challenge: the sea itself. Saltwater is relentless, capable of eating through unprotected steel in months. That's why surface treatment and finishing are among the most critical stages of production. This is where the chain's strength meets endurance. The process begins with shot blasting, a high-pressure cleaning stage where thousands of steel pellets are fired against the surface of each link. This removes any scale, rust, or residue left from forging and heat treatment. The roughened texture it leaves behind also improves adhesion for coatings applied later. It's a violent process, but necessary to prepare the metal for protection. Once the surface is cleaned, each chain length is chemically washed in an alkaline solution to neutralize impurities. Automated cranes then lower the chain into galvanizing or coating tanks, depending on the customer's specification. For most marine applications, the preferred method is hot-dip galvanizing, submerging the steel into molten zinc heated to over 450 degrees Celsius. The zinc bonds metallurgically to the steel, creating a corrosion-resistant alloy layer. When exposed to seawater, the zinc slowly sacrifices itself, preventing the underlying metal from rusting. For chains used in offshore rigs or military vessels, additional layers are applied. These include epoxy coatings, polyurethane paint, or even thermal spray aluminum, each designed for specific conditions like temperature variation or deep sea pressure. After coating, the chain passes through a curing chamber where controlled heat hardens the protective layer. Every section is visually inspected, weighed, and measured to verify coating thickness. Any inconsistency can lead to rejection. Once approved, the surface is polished and lubricated to ensure smooth operation through anchor handling equipment. Before shipment, a final marking and certification process takes place. Each chain segment is stamped with its batch number, steel grade, and test certification, traced back to its origin, forging, and heat treatment records. Documentation ensures compliance with international marine standards like ISO 1704 or ASTMA 391. By the end of finishing, what began as raw molten steel has become a high-grade industrial product, built to withstand decades of exposure to salt, pressure, and motion. The chain is now complete, ready to be assembled into colossal lengths for deployment across the world's oceans. From here, the journey leaves the factory floor and moves toward its final purpose, serving the ships, rigs, and ports that drive global trade. After months of production, every link now carries its own serial identity, proof of strength and precision. But the story of the world's strongest anchor chains doesn't end inside the factory. Their true test begins once they're assembled, shipped, and deployed into the harshest environments on Earth, the open sea. In massive port facilities, completed chain sections arrive in 50 to 100 meter lengths, coiled onto reinforced pallets. Each segment weighs several tons, and technicians inspect them again for coating consistency and mechanical defects before assembly. Specialized cranes and hydraulic rollers lift and connect these segments using joining shackles, precision-engineered links that allow continuous chains stretching hundreds of meters long. The alignment must be perfect. Even a millimeter's misfit can compromise the chain's performance under load. Once fully assembled, the chains are transported to shipyards and offshore platforms around the world. Heavy-duty trucks and cargo ships carry them to destinations from Norway to Singapore, often requiring weeks of logistics planning. In major shipyards, marine engineers use massive windlasses and chain lockers to thread each link into its anchor system. These installations require tight coordination. A single anchor chain can weigh more than 400 tons, and positioning it demands millimeter precision. Before deployment, proof testing ensures every link can handle the forces of the deep. Hydraulic tension machines simulate real-world loads, stretching the chain with pressures exceeding 1,000 kilonewtons. Any deformation, even microscopic, results in rejection. Engineers document every result, confirming compliance with marine classification societies such as DNV, ABS, or Lloyd's Register. Once cleared, the chains are loaded onto vessels, rigs, and cargo ships, their final homes. From here, they descend into the water link by link until they reach the seabed. Each connection bears the weight of thousands of tons, anchoring oil platforms, cruise liners, or container ships against waves, currents, and storms. Despite the scale, the process remains graceful, a seamless collaboration between engineering and nature. But even after deployment, the work doesn't end. Maintenance teams regularly inspect chains for wear and corrosion. Damaged links are replaced at sea using portable welding systems and specialized divers. The goal: ensure reliability and safety in conditions where failure isn't an option. From foundries to oceans, every link tells a story of human precision meeting natural power. What began as raw steel forged in fire now safeguards billions of dollars in maritime infrastructure. Each chain, and silent yet vital, holds the strength of nations in the rhythm of global trade. From blazing furnaces to stormy seas, the world's strongest anchor chains endure forces that few materials ever face. Every link forged, tested, and deployed represents decades of progress in metallurgy, design, and engineering. a silent partnership between human innovation and the power of the ocean. These chains hold the foundations of global trade. They secure oil platforms that fuel cities, stabilize cargo ships carrying millions of tons of goods, and anchor vessels that connect continents. Without them, maritime operations would crumble. Ports would stall, transport would halt, and global industries would lose their balance. Each link is more than just steel. It's a symbol of reliability. Built to withstand the crushing depths and relentless salt water, every millimeter of metal serves a purpose. And behind that purpose lies an ecosystem of factories, workers, and technologies, all working in perfect sequence, from molten steel to open sea. So the next time you see a ship resting calmly at the dock or anchored offshore, remember that stillness is held together by thousands of tons of engineered strength beneath the surface. Chains that never rest, never stop, and never fail. If this journey amazed you, share, like, and subscribe, and don't forget the bell, so you never miss how the world is made, from start to finish. Up next, how billions of crocodile skins are transformed, from jungle to luxury product.